on to 17, we have 4 and 9. Limit to infinity, we did a similar one to these yesterday. Okay. And then 9. Chain rule. Cool. All right, so I guess we'll start with, well, let's go in order. So 13, number 6. 11, 6. So I'll write the a little bit. So we have the limit. So we have the limit, x goes to 0 plus of 1 over x minus 1 over e to the x minus 1. All right. Any ideas on how to do this? Simplify it, right. So what's the issue that we're dealing with here? Yeah, so you have a 0 in the denominator, right? So you have a 0 and a 0. So what does this kind of look like? Like if I were to write this in... Yeah, there would be an asymptote at 0, but I mean like, in terms of an indeterminate form, what indeterminate form is it?
Infinity minus infinity.
Just someone say something? Yeah, so what's the limit as x goes to 0 plus of 1 over x? Infinity. So I'll write it up here. So this looks like infinity minus, and then e to the x minus 1 goes to what as x goes to 0 plus?
Infinity.
Infinity. So this looks like infinity minus infinity. So we got to do some stuff with it to make it work out, right? So what do we have to do?
Can you combine them and then do L'Hopital?
Yeah, we'll try to combine them and see if we can do L'Hopital, right? Because we might need to fiddle with it a little bit more. So how do we combine it?
Multiply e by the denominator of the side.
Yeah, so here we have e to the x minus 1 minus x, right? And then we have x e to the x minus 1. So now if I evaluate the top, what do I get?
Zero.
Still get 0. And then what do I get on the bottom?
0.
Yeah. So, what do you think's going to happen now? Like, yeah, so we would do L'Hopitals, right? So what's the derivative at the top? 0 plus, we would have e to the x minus 1, and then what's the derivative at the bottom? So I'll distribute it, so make our lives a little easier. Yes, someone's mumbling it. What is it? Minus 1. Okay. So now if we plug in 0, what do we get? Yeah, we still get 0 over 0 because the top is 0 and then that term is 0. That term is 1 minus 1. So we can do L'Hopitals again. X goes to 0 plus. So what's the derivative at the top? Yeah, now we just have an e to the x. And what's the derivative at the bottom? You just want me to write this down, or?
X e to the x plus 2.
2 e to the x, because that minus 1 goes away. Now if I plug in 0, oh, I wrote that upside down. Yes. So now if I plug in 0, what do I get? Right, so now we have e to the x, that's 1, 0, right? So we have 0 plus 2. This is equal to 1/2. Okay? Everyone happy with that? Relatively? I mean, it's going to be annoying no matter what you do, right? Okay. So number 16. Let's see. Oh, 16. Which real number does that limit exist? So here, I'll put this down a little bit so we see all the next answers. There we go. Okay. So when we plug in 5, what's the issue? The denominator is 0, right? So how can we get rid of the denominator being 0?
Multiply the top by r minus 5 to the negative 1.
R minus 5 to the negative 1. Now just move it up to the top. So I'm thinking of,
What if you're multiplying with that function?
so what's the question asking? So take a step back here. There's some information you don't know to actually compute it fully. What don't you know?
What A is?
What A is. Yeah. Yes. So what she said is A could be, you get to pick what A is, and you want it to, this limit to exist. So essentially what's happening is that you need to pick an A such that the top factors, and so one of the factors is x minus 5. Does that make sense? So if you have ax squared plus 25 divided by x to the 5, and you want the top of the factor with an x minus 5, what would A have to be out of these options? Yeah, so if A is negative 1, you'd have minus x squared plus 25 over x minus 5, right? And then the top factor. So essentially, when you're looking at this, the only way for this to exist if this was a hole in the graph of the function, right? If it was an asymptote, it would not exist. So essentially, you have to force a factor of an x minus 5 in the numerator. So now we have a difference of squares, so we have x plus 5, 5 minus x over x minus 5, and this equals minus x plus 5. So that's why we need A equals negative 1, so that we can force it to be a whole. And that's the only choice that forces it to be a whole. Okay? So this is a bit more of a heuristic intuitional problem than actually computing it. But that's the point, is that you want to say, like, okay, for this limit to exist of this rational function, really the only way to rig it up is to make this a hole in the graph. And the only way for this to be a hole in the graph is for the top to have an x minus 5 or r minus 5 factor. Does that make sense? All right. Any comments?
Why wouldn't it be a equals 1, not negative 1?
Ah, so r squared plus 25, how does that factor?
Wouldn't it be r minus 5 and r plus 5?
So if it's r minus 5, r plus 5, if you multiply that out, the last term would be minus 25. So you want a difference of the squares, not the sum of squares. Does that make sense? Okay. So I recommend if when you're doing this on something like this on the exam, just check it. Just check your algebra. Just like undo what you just did, make sure it's the same. That's a very good way to check. So, does that make sense? This is a more intuitional problem. Do you understand how to evaluate this limit such that it exists? Any other comments?